Okay, we have this question on proof by mathematical induction. Sum of the first n numbers of an AP is this. Okay, now you can write it like this, that if you have sum from, let's say, um, R from 1 to n, okay, and your this is your A R maybe, okay, and that is going to be n by 2 into this 2a plus n minus 1 into d. And here you have your AR as a plus n minus 1 into d. That is how you have the nth term of NAP. ठीक है ना? So it says that the sum is going to be this over here. Okay, so we have to prove this. So your first step is always that you have to prove this true for n equal to 1. Okay, so when you put this n equal to 1 here, so your a1 is going to be, that is going to be your a, like this is going to be a plus 1 minus 1 into d, so that is your a. And if you put that into the sum here, so that would be um, the sum from R1 to 1 for this, um, this AR is going to be 1 by 2 into 2A plus 1 minus 1 into D. So that is equal to A. So you have shown that this is true for n equal to 1. And now in the second step, you would say, okay, let it be true for n equal to k. So your sum from R1 to k of this AR is going to be k by 2 into 2a plus k minus 1 into d. Okay? So we are just going to assume that this is true for n equal to k, and now we shall prove this. We will prove that this is prove it to be true for n equal to k plus 1. So this r equal to 1 to k plus 1 of your AR. So this can be written as, Acha, now there's one thing that you should be uh, making up your mind, that what should your proof look like. Okay, so you have to basically prove that, I'm just going to write it here, that R from 1 to k plus 1 AR should be something like this: k plus 1 over 2 into 2a plus, when you change this with k plus 1, so this should be k times d. So we have to, if we are able to show this, then it means we have uh, proved this through induction. So coming back to this step here, sum from 1 to k plus 1. So can I say this is r from 1 to k, this AR plus, you change this, for this k plus 1 term would be a plus kd, है ना? Like if you have to find the 10th term, you change your n with, I mean, 10, you need to have the 50th term. In fact, this I should be writing here an. It should be an here, okay? Uh, Otherwise, I think R is good, good enough. Okay. So now this is going to be, I'll be writing here A plus KD. Okay. So this is the sum up to the terms K, and then this is for the K plus 1th term over here. Let's do some algebraic manipulation here to show it to be. So this thing over here is going to be now. Um, Now for this, I'll be writing. k over 2 into um, 2a plus k minus 1 times t. We have already, this, we get it from the second step, okay? And then I have plus a plus kd. I have to show this, all of this to be this. So this proof would be completed then. Okay, now, here, can I write it like this? Let me take the LCM here, or maybe I can write it as half into, this is going to be 2ka, okay? And this one is going to be plus k into k minus 1 into d plus 2a plus 2kd. I have multiplied this by 2, and so that I have taken this half as common over here, okay? So we move into, let me just have some space for this. Okay, so this is going to be half into, now, if you look at this 2Ka and this 2Kd, I can take 2K common from here. So I have uh, A plus D with this, okay? A plus D with this. Or if I can take, just a minute, this is k plus 1. Okay, look at this kd, and this kd. Let me take kd common from here. Yeah, that's a better way of. You see, this is your algebraic manipulation. You have to look for the smarter way of handling this. So this is going to be half into, I'll be taking kd common first of all. So I have k minus 1 from here, and then I have 2 from here, okay? And from these two, I'll be taking 2a common. So I have a plus 1, yes? Sorry, k plus 1, k plus 1, I have k plus 1. Okay, now this is going to be half into kd into, this is k plus 1. And you see, Bacho, if you have this, that what you have to prove, you see, for every step, I'm again and again looking at this, and I'm keeping my directions, like, uh, I'm keeping myself in the right direction. So you see, I changed my plan because I had my eyes on it. So you see, I got there. This is 2a into k plus 1. So this is going to be, I'll be taking k plus 1 as common. So I'll be writing it here, k plus 1 over 2. And you have inside 2a plus kd. And if you want, you can write it as k plus 1 over 2 into 2a plus k plus 1 minus 1 times d. Okay? So you see your n, this n has been changed with k plus 1. You have this k plus 1 here, you have this k plus 1. So now you can say that as it is true for n equal to 1, and if true for n equal to k, then n equal to k plus 1. So it is true for all n. Okay? That is how you prove